Can you hear me, Dr. Paul?
Oh, wait, there you are. I can barely hear you.
Wow.
The absolute worst place to do this call from. It is, I'm on a patio at a hotel, and a giant thunderstorm is rolling through right now. It's very cozy.
It looks cozy, and we can barely see you, but it's...
barely hear you. You sound like you sound very quiet. I was trying to think of a very creative metaphor.
You couldn't come up with one?
I couldn't come up with one.
Okay,
if I rearrange my earbuds to get them more in my ear hole, I might be able to hear you better.
Where are you?
I'm in DC.
That doesn't look like DC.
Shoreham Hotel.
Okay, so you can barely hear me. Is it because of the weather? Because my mic's...
I'm guessing it's like this super loud rain crashing all around me and the thunder.
Yeah, it looks like you're in a treehouse.
This is my treehouse. No girls allowed. I'll let you stream in, but that's it.
That's actually very generous of you. Some people won't let that even happen.
Yeah, well, I try. I'm a much more modern treehouse interpreter. I try to keep up with the times.
Yeah. So, guys, this is Dr. Paul, and we were just
Hi.
we were just reading an article that mentioned your name. It was kind of scary.
Oh no.
Yeah, I didn't expect it.
Did I write it?
I wasn't trying to promote you, but you ended up being promoted.
I can't help it, guys.
Oh my goodness, you exist. We see you now.
It brightened up, you decided to make everything brighter.
Yeah. Wow. Hi.
Hey.
So you kind of look like you're not so much in a weird place anymore.
Yeah, so I was going to move the camera to show you. The back of this hotel has a lovely garden, very French style garden, and beautiful rain. But now I'm dark again.
Yeah, yep. That auto exposure.
I think if I shift more away from outside, how's that?
That would probably be more stable.
And I have to hold my earbuds perpendicular to my head.
Okay. So you didn't bring your book with you?
As soon as we left, I thought, I did not bring my book with me.
No.
And I was thinking about doing this stream today, coming on your show.
Do you feel dead inside?
I don't have my book.
You feel lonely without your book?
I usually carry me with it constantly. I do have a digital copy of my book.
Oh.
Wait. Here we go.
Perfect. Can totally read that. Not any problems at all.
I have no idea what you just said.
It's okay. It's all right. So
it was just a joke.
I know. A little bit. Couldn't make that out. Be right back buying a digital copy, someone says. Can you read chat at least?
Yeah, I can read chat. I'm good. I'm on the chat. There's my digital copy.
Oh, okay. So yeah. So I can kind of your place in the universe.
Yeah.
Yeah.
I have this digital copy because my indexer is making an index.
Oh, nice. So
it turns out that's a really, really complicated process.
Why?
Because I guess you don't just take all the words. You only take the words that people would care about. Like you don't count all the times I use the word other or might or critique or besides. You care about words like cosmology and Maxwell and Big Bang.
They care about Maxwell.
Maxwell. So Maxwell is like one of my favorite scientists of all time.
Mm-hmm.
And he barely comes into this story, barely. So I gave him a footnote where I apologized to him for not including him more in the story.
Oh.
Poor Maxwell.
Okay, so we're definitely still getting audio peaks, which I think is probably Zoom. But it's okay.
I'm guessing it's Zoom because I'm not using, as you can tell, I'm not using my fancy, expensive headset.
Right.
That you forced me to buy.
Right. That $70 headset.
Yeah.
Yep. I know.
We're not going to blame that for the peaks anymore.
I think it's definitely a Zoom thing. But, it will just keep people on their toes.
Loud.
Well, maybe.
It just doesn't like my voice.
I don't know. I think it's definitely a Zoom issue, but we couldn't tell. I could tell. I could hear it. Anyhow, so the article we were reading was about neutron stars.
All right.
Yeah. So I'm talking to people about neutron stars. Do you want to talk about neutron stars? Do you want to give people your sell on it?
People that you talk about neutron stars. So what I say in the article, was it something dumb?
No, it was actually really good stuff. But like I was kind of skimming through it and answering questions, that were non-relatable, but it was totally fine. So yeah, let's see, what's the name of the article here? It is, I'm looking at it right now. It is Neutron Stars Definition and Facts from this year in February.
Really?
Yeah, and they dropped your name. They said the average neutron star boasts a powerful magnetic field. And then you said how Earth's magnetic field is around 1 Gauss, and then the sun's around a few hundred, or Gauss. You could say Gauss.
Gauss.
I mean, Gauss would be more accurate, but I'm going to just act like I'm an American. And so
we say Gauss.
I know. Gaussian. Yeah, I should
make the sh sound and it'll be really cool.
So it says that the sun's around a few hundred Gauss, and that's according to astrophysicist Paul Sutter.
That's me.
That's
right.
you.
I see. It's a space.com article.
Mm-hmm.
Okay.
Yeah. So
and then they link to what may have been my most popular article ever.
Really?
Which is why Magnetar should freak you out.
Yeah, so talk about, okay, so I'm going to show everybody that real quick here now. Yeah, so why should this freak people out?
Yeah, if you're anywhere in space and you're close to a magnetar, move away as quickly as you can. Magnetars are even more deadly than black holes.
Okay, I'm going to write that one down. I hope chat's writing that.
There was an ominous crack of thunder. I don't know if you caught that. That was so perfectly timed.
Yeah, and I was about to say.
I could not pay for that time.
It did make it seem a little bit more ominous.
Yeah.
A little bit more dark and yet ominous, like mysterious. We have no idea what's going on.
Yeah, they're just dangerous.
Dr. Paul's volume is a bit low. Is it a bit low? I need more people telling me that because I rely on my chat.
I can bring the microphone closer to my face.
It is. Why didn't you guys tell me that? Everybody's like, low AF, better, perfect. Oh my goodness. Guys, you need to.
Low.
You. Chat failed me. Better. Okay. We were being polite. Okay. Being polite is telling me.
I'm trying to find the right earbud position.
Okay, well, I think that's better. We failed. Get out of here.
I'm taking out a lot of earwax with this process.
So really, you can't hear me at all? That has to be a Zoom setting as well because I'm pretty loud, actually.
So in general, I know you're an incredibly loud person. And even with the headset, you always come out a little bit quiet. So I wonder if Zoom is keeping us down.
It's holding us back.
Yeah.
Great.
Zoom is not letting us realize our full potentials.
Yeah. Okay, so magnetars, you don't want them close to you. And why don't you want a magnetar to be close to us? Like, why? I think that sounds like a hell of a party.
Yeah, it sounds like a party.
Yeah.
And it is a party for your electrons and protons, but not a party for your nervous system or your body. So magnetars, as the name might suggest, they have incredibly strong magnetic fields. We're talking 1,000 trillion times stronger than the magnetic field of the Earth. And they are by far the strongest magnets in the entire universe.
In the whole universe.
Everything. Beat everything. Nothing has a stronger magnetic field than a magnetar.
Wow. And so
they're so magnetic, they got their own name.
Right.
Magnetar.
So, but okay. So for anybody in here that doesn't know what a really, really strong magnetic field would do, what would it do to you?
Yeah, this is the crazy part because we're so used to magnetic fields like not mattering at all. Where, oh, you might pull out a little compass and it'll wiggle your little compass around, and that's it. Like, that's the entire extent of the Earth's magnetic field. That's all it can do to you. But has anyone in the chat ever done an NMR?
A what?
The scanning thing.
MRI?
The medical scanning thing, nuclear magnetic resonance scanning.
Wait, whoa.
It's a thing.
Everybody's saying
Not
ASMR. Is it an MRI? Oh, sorry, I just hit my mic.
Yes, MRI.
Okay, an MRI. I've had an MRI, yeah.
Okay. So you know how they make you like not want to have anything metal in your pockets when you do those things?
Uh-huh.
So the reason they don't want that is because those magnetic fields are like 1,000,000 times stronger than the Earth's magnetic field. And that strength of magnetic field can start flinging around metal objects. So
Okay.
it's not pretty. And if you take a magnetar, which is 1,000 trillion times stronger than the Earth's magnetic field, these magnetic fields start bossing your atoms and molecules around.
Oh, no.
So a proton will want to go one way, an electron will want to go another way.
Uh-huh.
These magnetic fields can actually take atoms and squeeze them so that they're more pencil-shaped
Uh-huh.
than round.
Uh-huh.
And that screws up all of chemistry.
Uh-huh.
And your nervous system just breaks down because your nervous system is sending electrical signals back and forth across your body. And if you get within about 1,000 miles of a magnetar, you simply dissolve.
Great.
You straight up stop existing as a single object.
So I might not RSVP to that party then. I might not go.
If you get the magnetar invite, just pass on that. Just pass on that.
Okay.
Or give it to your worst enemy.
Oh, great. Chat. I'm kidding. No, so
Hey, chat.
Hey, chat. So we have magnetars. So are there any kind of neutron stars? Because it's a type of neutron star, correct?
Exactly. A magnetar is a certain kind of neutron star.
Right. So do we have any that are nearby? Because I guarantee that's going to be the next question, right?
I think the nearest neutron star is something like 10,000 light years away. I could be wrong on that. It's in the thousands. And then the nearest magnetar is even further than that because they're much rarer than the neutron stars.
You mean pulsars?
So pulsars are also a kind of neutron star.
Right. And would you say, so as far as neutron stars go, what's the most common type of neutron star? Just a generic neutron star?
Yeah, I would say generic neutron star. If they happen to line up just right, we see them as a pulsar. And if they happen to be spinning incredibly rapidly, they are also a magnetar. So pulsars can be magnetars, but they don't have to. All magnetars are pulsars. Not all pulsars are magnetars, but all pulsars and magnetars are neutron stars.
That last bit definitely did not confuse anybody, but it's okay. I'll recap that like 5 or 6 times today. So it's totally fine.
We need a Venn diagram here.
We do. And you know, my paint skills are just, you know. So with someone asked, and so with these magnetars, the generation of a magnetic field, is that because you still have electrically charged particles existing within them?
Yeah, that's exactly right. So neutron stars, despite the name, are only majority neutrons. They do have a tiny bit of protons snuck in between their layers, like butter in a flaky pastry dough. Mm-hmm. And then they also have an electron crust, like candy coating. And so these positive and negative charges are spinning rapidly because neutron stars spin crazy fast. We're talking tens of thousands of revolutions per minute. That's something like a kitchen blender, but the size of a city. And this generates wicked strong magnetic fields. Wicked.
Someone says, is there a relation between mass of the former star and whether it becomes a magnetar or a pulsar? That is a good question.
That is a good question. That is a really good question. So neutron stars exist all in a relatively narrow window of mass. There's a certain minimum mass you need to build a neutron star, and then a maximum mass before it collapses into a black hole. And we're not exactly sure on those boundaries. It's somewhere between 2 to maybe 4 times the mass of the sun.
Yeah.
And we think that when neutron stars are first born, they're spinning incredibly rapidly, and that's their magnetar phase. And then slowly over thousands of years, they slow down and their magnetic fields weaken, where they become declassified. They still have really strong magnetic fields, but not enough to become a magnetar. And the pulsars, so as a part of this whole spinning process, what the pulsars or what the neutron stars are doing, they eject beams of radiation out of their north and south poles. And these beams of radiation, when they intersect with the Earth, we see a little flash of light that pulses, hence the name pulsar. But if it doesn't line up, if it's pointed in some random direction in space, we don't get to see it as a pulsar. So whether we see a pulsar or not just depends on our lucky incidence of observation.
Okay, and that's likely because we got that alignment going, right?
Exactly. It just happens to be pointed at us.
Gotcha. Is that the threshold that's hard to pronounce? Yeah, that's the Chandrasekhar. Chandrasekhar limit.
Chandrasekhar. It's probably not how he pronounced it.
Probably.
I'm guessing.
I know, but that's how we pronounce it. So that is that limit.
Subramanian Chandrasekhar.
Yeah, and that one, we've actually had a lot of changes. Even though it's a very small window, it's still not really largely agreed upon, that window. It definitely is a dynamic thing. It changes all the time.
Yeah, because really we have no idea what's going on inside a neutron star.
Yeah. So I know that we were talking about this. Everybody was asking me what neutron stars were made up of. And I said, just exactly
neutrons.
Neutrons mostly. But, you do get protons and electrons and, and neutrons
some salt in the mixture.
Right. You got neutrons created through that whole what was it? Electron. God, what was it?
Reverse beta decay.
Oh, my goodness.
Something like that.
Yeah. No, the electron capture.
Electron capture.
I mean, I think that sounds a little bit, I'm trying not to intimidate my chat, Dr. Paul. Okay.
No, I get it. There's lots of cool jargon here.
There is. No, it's really, really cool. But
so we'll settle with just Chandrasekhar.
Yeah. And so, but that's anywhere between, what? Like, I've heard the lowest part of that limit is like 1.5 times the mass of our star to, like 3 or 4.
Yeah. So a white dwarf star, that's around 1.4 times the mass of the sun. And that is the Chandrasekhar limit for creating white dwarfs. And then to make a neutron star is going to be heavier than that.
Yes.
So we know the minimum, but the maximum is where we have a lot of questions.
Yeah. Was there something called strange matter also inside a neutron star? So that's, the ultra cold dense matter, right?
Yeah, or whether, so the question here is, okay, if you have an object made of a bunch of atoms, it's like a normal star, then you squeeze it down and you make it a white dwarf star. Then you squeeze it down even further, you make a neutron star. But neutrons themselves are made of smaller particles called quarks. So could you make a star out of just a ball of quarks? That we honestly don't know. It doesn't seem likely, but there are some potential inroads in both theory and observation. And it could be that the interior of a neutron star, the very core, the nougaty creamy center, is really like a goopy soup of free floating quarks in what we happen to call strange matter.
Yeah. And I mean, isn't that something that we thought of? Like, so I've heard it called this cool ultra dense matter. That's what I've heard.
Right. So we honestly don't know. The interior of a neutron star is just question mark. We don't know. It could be this ultra exotic agglomeration of neutrons in a very weird state. It could be a different state of matter altogether.
Yeah, because I mean, what we know is that basically the density of matter grows, right? When you have it grows to a significant, so it grows so high that particles touch each other
They get
and that
smooshed together.
Right, and then that's a strong force. It becomes the overall, like, I'm going to dominate this whole interaction, right?
That's exactly such a jerk.
I know. Strong force is a complete jerk.
So bro.
It's so bro. It's so bro. Bruh. But yeah, and that's what we know so far is that the strong force is doing a bunch of really weird things with neutron stars.
And we don't 100% fully understand the strong force, especially in such exotic scenarios.
Yeah. And someone said I need a pet named Quirky. We don't like to use the term strange matter, rather normality challenged matter.
No, strange matter. It's strange. We're owning it.
Yeah, and
we're owning our identities.
Yeah, I like strange matter.
I like strange matter, and it's the reason. So, I don't want to scare off all your
No, it's okay. I told them that you would be, no pun intended for this talk, but it'd be a little bit more dense with you on.
Too funny. Yeah. So the reason we call it strange matter is that there are 6 kinds of quarks. Are you ready for what they're called?
Totally.
Up, down, top, bottom, strange, and charm.
Wait, what was that last one?
Charm, as in you're so charming.
A charm quark. Great.
Charm quark.
Great.
Yeah. Like charm bracelet, charm quark, same deal. So almost all the matter in this camera, the matter in this table, matter in my body, those protons and neutrons are made of up and down quarks only. So if you're like, okay, I've got a ball of neutrons, I'm going to squish them down. I'm going to just have a soup of of up and down quarks. That instantaneously destabilizes. It falls apart. You can't build a big ball of up and down quarks. But you can maybe add a few more maybes onto that. Make a big ball of strange quarks. There is a quirk in the quarkness about them that potentially allows them to form macroscopic objects. So if there's a big ball in space made of quarks, it's most likely going to be just strange quarks, hence the name strange matter.
Great. So can I not have to explain to people that we don't know what strange matter is too? Because I'm already having a really hard time having to tell people that we don't know what dark matter is. Like we kind of understand it a bit, but like not much.
Yeah.
I just don't want another kind of matter that I have to keep saying, I don't know.
I'm sorry. We're on the boundaries of known physics here.
I know.
Give us a few more decades and maybe we'll figure it out. And then you can go back to your stream and you can be all confident. If we want to talk about how comets work or something simple, I can show you how craters work. If we want to go back 300 years in astronomy, this is the edge.
I can go back to my stream. Not all matters matter. Wait, yes, all matters matter. But no, like having something that's like strange matter and people are like,
dark matter, phantom, and there's a lot of matters because there are a lot of theorists with nothing else to do.
Yeah. I don't. I already have enough problems with dark energy and dark matter. Like that alone.
Let me put it on the hierarchy. Dark dark energy, total unknown.
Yeah, complete mystery.
Totally clueless. And just spit as I said that to emphasize.
No one saw it. It's okay.
It's on my phone.
It's on my phone.
Dark matter. We have some vague ideas.
Yeah.
Strange matter, hypothetical possibility, but not exactly favored.
Hypothetical.
Hypothetical. It's an idea.
Yeah. So and wouldn't that whole idea of just like this misunderstood or not really known matter, that would probably make a bunch of theories being, even more challenging? Because experimentally, what do you do? How do you do anything with that experimentally?
So what we do to study the nature of quarks, and by the way, the last quark to actually be detected was the top quark. The top quark was finally observed in something like 1996.
Naturally. Go on.
Yeah, 90s, great time. And the last one to be measured was the top quark. And so we study quarks in two ways. One is through particle colliders. We blow stuff up. And since stuff is made of quarks, we get to see all the blown up bits.
Right.
And the other way is through extreme astrophysics. If we look at the properties of neutron stars and we try to make a guess, like, oh, maybe it's a quark nugget in the middle. Are there any observational consequences of that we can measure in, say, the rotation rate of the pulsars?
Yeah, and someone was asking, how would we actually measure the radius of these pulsars? How do we do that?
So we measure the radius. Like, we actually don't have a firm, observation. It's not like we have pictures of neutron stars and pulsars, because they're really small and they're really far away. Instead, what we can get is the mass. If there's something orbiting that star, we can use Kepler's law. We can get a really, really good solid estimate of the mass. And then from there, we turn to physics. We turn to calculations. We turn to simulations to get estimates of the size of the object and the internal properties.
That was the answer I gave, but I just wanted to make sure it came from a PhD.
Yep, you just wanted that stamp of approval.
Just wanted to be.
I'm here. Yes, Guy, you're correct. Yes, Guy, you're correct. Yes, Guy, you're correct.
I might have even used the word radial velocity if it was a binary companion. So if it had a binary companion, I know, but I was
now who's the jargon slinger?
I don't know.
Paul's gonna come on here and be all dense and talk all sciencey and mathy.
You dropped the Q word though, so.
Quark?
Yep, that one. So
the origin in that, I can't. So particle physics drives me nuts, and there's a chapter in my book because I have to get into particle physics because I'm trying to explain early universe stuff.
Right.
And it drives me insane how complicated and jargon heavy it is. It makes it so hard to communicate.
Do you think that's why Stephen Hawking stayed away from it because he tried to stay away from it as long as he could doing cosmology, right?
I think Stephen Hawking was just in his own little world. Like he was trying to understand the gravitational nature or the quantum nature of gravity, and which is different than a lot of high energy particle physics. Every once in a while, he would dabble into high energy physics and he would get stuff totally wrong because he wasn't paying attention to updates in the field. And so people like Peter Higgs would have to call him up and say, Stephen, listen, knock it off.
Knock it off.
Knock it off.
You're at an 11 and I need you at a 5.
Just roll on over there, pal.
Someone said, what's your thoughts on the LQC to explain early universe phenomena?
LQC stands for loop quantum. I was going to say gravity, but that's G. Did you mean LQG?
He meant ICQ.
ICQ. I remember ICQ. Those were the days.
We'll wait for.
We're gonna wait. Oh, loop quantum cosmology. Okay. Fair enough. Loop quantum cosmology is related to an outgrowth of something called loop quantum gravity, which is a very hypothetical quantum theory of gravity that is full of mathematical monsters that no one knows how to slay.
Wonderful. That was a real precise breakdown of that. And so we do use, so I'm going to throw another acronym. We do use the LHC, which is the Large Hadron Collider, to study quarks, though, you said, right?
We do. And we use SLAC.
SLAC?
SLAC.
I just know that as a software.
The SLAC, the Stanford Linear Accelerator Collider.
Oh, right. And that's in Palo Alto, right?
That is it's in Palo Alto.
Yeah, I think it crosses over at Highway.
I think so too.
Yeah, I think I saw it and I was like, I think that's a collider.
I think that's SLAC, guys.
Yeah.
They're like, what, you the company? Mm-hmm. That's based in Palo Alto.
Someone's saying, is that related to string theory? ICQ related to string theory?
Loop quantum gravity and string theory are arch nemeses.
Mm-hmm.
They hate each other. They are competitive theories for making a quantum picture of gravity. They both have been around for decades, and they both miserably fail.
Great.
Yeah.
So you mean string theory's not doing so well?
String theory is not doing so hot these days.
Yeah. No, I have to just get, I was thinking I should just get you to say that. Like, that should be a part of your introduction. Hi, I'm Dr.
Everyone,
Paul.
I'm Paul Sutter, astrophysicist at Ohio State, and string theory is not doing so hot these days. I should go up like a weather forecaster, get me a green screen, and the outlook for string theory, it's not looking so good. Some clouds on the horizon, gonna make that morning commute difficult. Back to you, Sky.
We should actually have that be a thing. Because that's amazing. Because there's so many people that come in and be like, tell me about string theory. I'm like, I'm not really going to get into it. But yeah, that would be amazing. We could just do a weather forecast, and every day we just check in on string theory, and it's never, hello, string theory. How are you today? But yeah, we should get Dr.
Like or it could be like Mr. Rogers' Neighborhood, like have a little hand puppet. Hello, string theory. How are you? I feel sad. Why do you feel sad, string theory? Nobody believes me. Well, why doesn't anyone believe you, string theory? Because there's no experimental verification, and the fundamentals of my theory are falling apart. Oh, that's too bad, Mr. String. Would you like to get some ice cream? Sure. That sounds great. I could do that all day.
No, I think that I don't know why I've never come up with a hand puppet. I think it would
Why have we not thought about this before?
I don't know, because there's a lot of things I feel like I could communicate better
With
if I were just
It's like Alton Brown.
Mm-hmm.
We need hand puppets around to explain. Now of all the particles and quarks and leptons and mesons and baryons and neutrinos, that's where we could really get the hand puppet story, the whole deal going.
Joe says he's going to contact HBO. Thanks, Joe. Appreciate it.
Pushing those high-level leads. I'll get a deck together right now. We'll make the pitch.
Exactly.
I get to hold the hand puppets now.
Yeah, someone says from an experimentalist perspective, the forecast for string theory is never good. Yeah, I'm just looking through the rest of the questions because I know... this is a question from a while back. Speaking back to magnetars, if two were to be in radius of each other,
like collide
of each other, would they repel each other or swallow each other if they were different sizes? And I don't know if he means by different sizes in terms of size or mass. Let's just say mass.
So even though they have incredibly strong magnetic fields, if they were close together, they both still have incredible amounts of mass. Remember, these things weigh like 3 times the mass of the sun.
Right.
And if they are close, they will actually orbit together, and they will spiral in, and they will eventually collide. We've suspected that these things have happened a lot, but it was about a year ago that we've got the gravitational wave discovery of the signal from one of these events. And when they explode, they're not as powerful as a supernova going off. They're about 1,000 times weaker, but they're still pretty intense.
Yeah, and they form a black hole, right? When they merge. It's
thought in some cases they may just obliterate each other.
Oh.
Where there's not enough bits and pieces in a dense enough environment to trigger the formation of a black hole. In some cases, they might settle together and just make a big neutron star. It depends on their masses.
Right.
The one we observed last year, we think that did make a black hole.
Right. Yeah, because there's going to be a limit to how big a neutron star can get.
Exactly.
So
We think neutron stars are the last bastion of matter before complete collapse into a black hole.
ooh, I like the way that was said. Bastion of matter.
And I'm hoping, because I used that line a month ago during a taping of How the Universe Works. So
Mhm.
you're going to see next January or February if they keep that line.
Watch, they're going to delete it like
I
a
was
week
very
before.
proud of that line.
They're going to take it out a week before.
Or this is what they do, those jerks. I give them really awesome lines,
Mhm.
and then they give them to like Phil Plait or someone else, and they have him say it. And I'm like, Phil, you gave Phil my line. That was mine.
Wait, so Phil's on the new How the Universe Works, like the ones that are up?
Yeah, he's in like every single season.
Oh, good.
Phil's awesome.
Yeah, but you're in almost everyone, right?
So I'm in this past season. This season that just ran is on repeats now. I'm in almost every episode. Next season, when it premieres next year, I'll be in every episode.
And are those being aired on the YouTube channel? Because I know they have the How the Universe Works YouTube channel. That just,
I guess.
did you know that?
I have no idea.
I just learned this.
Is it a locked YouTube channel?
It's like it's a live broadcast of just them running their episodes.
What I think they should do with that YouTube channel is they record so much stuff. Like interviews go on for days and days and days, and it gets compressed down to like 20 minutes tops of airtime.
Mm.
And they should just publish the entire interviews because they're usually really fun.
Yeah. Someone said, and I'm getting the other questions. So magnetic field of magnetars is still negligible to their gravity field at close range.
Sure. At close enough range, yes.
Yeah, and then Bill answered that too. And then can the implosion of a planet cause a black hole? Nope.
If
you have a planet massive enough.
If you're to take the Earth and somehow squeeze it down to be the size of a lima bean.
Oh.
You would have a lima bean sized black hole.
But that wouldn't last too long.
Yeah, I don't know how long it will last.
Yeah, I wonder how long a lima bean one would, like anything that we could create here in a collider would evaporate pretty quick, but
instantaneously.
A lima bean, yeah, it'd just be boop boop. So
I know there's a number. It's like the mass to the fourth power or something.
Mm-hmm.
I'm looking it up right now.
There's another question.
Mass cubed.
Is that type of
You want
collision?
me to run the numbers?
If you want, I can answer this question. Is that type of collision a lot weaker than two black holes that we detected gravitational waves with? Yes. The neutron star, again, due to their lower masses, they weren't able to generate a huge gravitational wave like two stellar mass black holes. When those two, we've actually had a few of those detected by LIGO. So the neutron star is going to be weaker, just due to the merger also not being as, the two masses of those neutron stars being lower than the masses of the black holes that merged. What's the expiration date of a lima bean? Commercial free, at least when I watch How the Universe Works through Chromecast. Yeah, I don't know if they're running like new recent episodes though. That's what I was wondering because I wanted to turn it.
I have no idea what they do.
Yeah, I wanted to see if you would pop up on it.
You're just looking out for me?
Someone said, is there an equation to find the time a black hole lasts?
I'm still figuring out the lifetime of an Earth mass black hole.
Mm-hmm.
I'm almost there.
Wait, what a macroscopic black hole evaporates so quickly through what?
A what?
Someone was talking about why we know that, if we created something in a collider here that was a small black hole, a macroscopic black hole, that it would evaporate. It would just
be microscopic.
Right. So what they're asking why we know that.
Oh, so one, we're not entirely sure. Oh man, it's like 10 to the 50 years.
Okay.
If you were to make the Earth into a black hole,
Okay, so it'd hang around for a bit.
it'd be a lima bean that would last for 10 to the 50 years.
So a bit.
If I did the numbers right. So yeah, a tiny bit. Would, you know, multiple times longer than the life of the universe so far.
Someone said, what is it meant by the black hole evaporating? Well, I just meant that it basically disappears, but you can get that confused with Hawking radiation. Yeah, I'm starting to get into that. I'm sorry, I pushed that button when I said it would just evaporate.
But it evaporates via Hawking radiation.
Yeah, we haven't done this yet, though.
We haven't done that one.
Right, we haven't tested this. This is all just what we think. I guess that means we would theoretically be hit by lima bean black holes.
That would suck.
That would really suck.
Fortunately, the only way we know of to compress objects that tightly is through gravity.
Mm-hmm.
And the only way to compress objects that tightly is to have a lot of stuff. You need at least 8 times the mass of the sun compressing in order to overwhelm all the other forces and build a black hole.
Right. Someone says, no, not microscopic. Why would the Earth mass black hole evaporate so quickly? It wouldn't. We were just talking.
It would take 10 to the 50 years.
Mm-hmm. Let's see. Are lima bean black holes regulated by FDA?
Yes.
Is this is the number I found through Google for the Earth mass black hole. We were talking about lima bean, but
oh no, so an Earth mass black hole would be the size of a lima bean.
5.1 times 10 to the 50. Yeah. Same number he gave. So that, yeah, that's that in years.
Yep, 10 to 50 years. Thanks, Chip, for checking my math. Zoto Turtle.
Mm-hmm. Awesome. And let's see here. So we have magnetars, and then so we have also those pulsars, but there's some that rotate very, very fast.
Yeah.
In that article that I was reading that you were mentioned in, they said 700 times a second.
Isn't that crazy?
Yeah. So why?
700 revolutions per second.
How? Why?
But we actually don't know how neutron stars spin up this quickly. We think there's a limit to how fast they can actually spin before there's some drag effects that kick in and must slow it down. To spin things up in space, you drop stuff on. If something's spinning and there's an object over here and you throw the object on, it's going to increase mass, which is going to increase its angular momentum, so it's going to spin faster. So maybe these objects, these ultra fast spinning neutron stars, maybe they've been accumulating material, and it's been like, when you're on the side of a playground merry-go-round and you're just spinning it faster and faster and faster until you puke. Maybe it's something like that.
Oh, so it's like, I could make you spin faster if I'm just throwing popcorn at you.
Yes.
Great.
If I'm in space.
If you're in space.
If I'm in space. It doesn't work on the Earth. I just get fatter on the Earth without the spin.
That's assuming that you'd be able to catch the popcorn.
I'm very good at catching popcorn.
I have
no doubt about that.
Someone said, I've heard that there are quakes on magnetars caused by thin iron shell breaking, and it causes burst emissions. Is that an actual thing?
Yeah, so the surface of a magnetar, or the surface of any neutron star, is one of the most extreme and alien and strange environments we can possibly conceive of. These places, the gravity is so strong that the tallest hill or mountain on a neutron star is like a couple centimeters, like an inch. And if you were at the top of that hill and you fell off, by the time you hit the bottom, by the time you dropped an inch, you would be traveling at half the speed of light.
Oh my God.
Yeah, these are intense places. And the outermost layer of a neutron star, we think, is an ultra hard, dense shell of electrons and maybe some nuclei like iron. And it's not perfectly uniform. Every once in a while, there can be like fractures or fissures, or a piece of the material can break and fold like this or reform. And we see these as glitches in the pulsars. So when the pulsar is sweeping by us and we see it and it goes pulse, 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 a few hundred times a second, it can all of a sudden change its rate of speed, its rotation rate.
Right.
And the only way to do that, we think, is by it's reconfiguring itself by having little neutron star quakes. It's intense stuff.
Yeah, and there was something else. So didn't NASA say something about there being a super fluid core too, though?
Yeah. So we're pretty sure that the core of a neutron star is almost completely rigid and flexible shell that sometimes cracks and fissures. Underneath that, there is a sea of neutrons that take up a variety of shapes. They fold in on themselves. We actually call this the nuclear pasta because the neutrons group together to form big lumps and tubes and strings. Underneath that is something. That could be quarks as a soup. It could be a ultra fluid or ultra dense fluid of neutrons. We don't know.
And someone says, do neutron stars feed at all like black holes? Yes.
So they do accumulate material onto their surface. So neutron stars can collect very dense atmospheres of hydrogen and helium. But if they eat too much stuff, if there's a layer of too much stuff, then that'll trigger a collapse into a black hole.
Okay. And let's see. If the matter comes in from the same direction, then it will increase spin. Matter coming from the opposite would decrease spin.
Right. So this is going back to the talk about angular momentum and throwing popcorn on the neutron star. So you're right. If it's spinning this way and I throw stuff here, it will spin it up. But if I throw it against the spin, it will
I'm going to
slow it
create
down.
resistance.
What's that?
I'd create resistance then. If
Yes.
I threw it against the
Yes.
direction you were going.
But thankfully, you know how our solar system, all the objects are basically going in the same direction around the sun?
Yeah.
Right. If our sun turned into a neutron star, all the planets would still go in the same direction. Then as they fell in, they would all contribute. They would add to that spin rather than detract. So there's a whole spin to the entire neutron star and its environment. And then as that whole thing collapses, it speeds up.
Yeah, except Pluto. Pluto would probably not be a great contribution. Kidding.
Okay,
I'm kidding.
Random dig on Pluto. Wow.
I just
didn't
needed
think
to
we were gonna
upset
get
Alan
personal
Stern.
here.
Just,
I think we're being all objective and excited about science, and then random. Pluto sucks, by the way.
By the
Wow.
way, we're going to get some poor Plutos in chat. Now everybody's posting
Yeah,
poor
there it
Plutos. Look
is.
what
There
I
it
did.
is.
Look what I did. Technically, all celestial objects feed or collect matter unless they happen to be the object being fed.
Sure. And I feed on calzones.
Yeah, and you had to mention pasta. I was hoping I could get through one space stream without mentioning some kind of pasta, like spaghettification or...
You can't, especially with neutron stars.
Yeah,
and
no.
We'll see. This is another segment I hope ends up in how the universe works. Because I told the producers about the nuclear pasta and how there's different kinds. How at the topmost layer, we think it's more like gnocchi, where the neutrons just group together into clumps. But then the clumps glue together and become strands, and it's like spaghetti. And then the spaghetti glues together, and it's like lasagna sheets.
Oh.
Then the lasagna sheets glue together, but then there are holes in it, so it's more like penne. And so
Wow.
they actually bought all those kinds of pasta.
Wow.
And I got to play with them on a kitchen counter.
I really hope they do that because I think that would...
That's a great segment.
Yeah, no,
I dump like bowls of pasta onto the counter.
Here is your astrophysicist, Dr. Paul Sutter, and his pasta.
And my pasta. And I ate a lot of raw gnocchi during that taping. And I'm not ashamed.
It's just
I was crunching
potato,
on
right?
noodles, and yeah, it was super noisy though, because you dump a bowl of penne out, and the penne goes everywhere,
Right.
which made for great sound, but was very distracting. So we had to do a bunch of takes.
Now we need that Dr. Paul with a little bit more enthusiasm. Okay? We need a little bit more energy.
Penne!
Can we please clip that for the love of God? You win, Dr. Paul. Now I want pasta. Yeah. So, is there? Do you guys have? Oh, wait. Do black holes attract each other? I mean,
Gravitationally, yes.
Gravitationally, if they're within a certain.
And sometimes they fall in love.
Sometimes they fall in love, but when they fall in love, like they just become one, though.
Yeah, they kiss, and then it's
But I
over.
feel like
They just become one.
It's an identity crisis on both sides.
It's a very codependent relationship.
Very codependent. Let's see. Someone else asked a question. Would two adjacent black holes align to each other as magnets do, opposing according to their poles?
So the environment around black holes and neutron stars, yes, the magnetic fields are big and bad and scary, but the gravitational forces are also incredibly strong, and the gravity dominates the interaction.
There you go. I added a sound effect to when you said dominates.
Dominates.
I was hoping you would pause for maybe like 2 more seconds so I could get that in.
Are you ready? We can
Yeah, all right.
We can do another take. This
let's
isn't
do
live
it.
or anything, right?
Okay. You have to answer the question. The gravity dominates.
Yeah. So around black holes, yes, the magnetic fields are very strong, but the gravity dominates.
Dun 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 dun.
That was your sound effect? Wow.
Yeah, I know.
cannot mask my disappointment. Okay.
People are giving me dots in chat. That was rubbish. Okay, no. That I'm sticking with that one. That one was amazing.
Yeah.
You're not even carrying on.
I'm looking at the clock, actually, wondering if it's 3 o'clock.
No, that's my job, is to be like, so you only got you got 8 minutes left, Dr. Paul. Make it count. That was so epic.
My book now.
That's a fang fail. Let's see. The Oscar for sound design goes to someone else. Great. Wonderful. I have a bunch of supporters in my chat, by the way.
It's an honor to not even be nominated.
Mm-hmm. It is. Yeah, we're working here on a budget. I'm not about to do my voice.
I know that story.
Yeah, no, I mean, I have a thing, but I don't know how loud it would be to everybody else. And
Make it loud. Just do it. It couldn't be worse than what just happened.
No, wait. Yeah, it could. Hold on. I think this is it. Hold on. I have to make sure. Wait, this has to be all the way here. This goes here because it's going to be loud.
Let's do it.
I think. Wait, let's see. Hold on. Wait. No.
No.
Wait. I'm trying to figure this out. Keep answering questions in chat.
Okay. So, chat, what'd you have for lunch today? I had a chicken pesto sandwich. It was pretty good.
Weird. It's totally not working right now, and I don't know why.
So, chat, have you bought my book yet?
You're really bad at this chat stuff.
Oh my god.
Whoa.
Yeah, so this would not be a dun dun dun. No.
I think this is what I would do.
Yes.
Right?
That's my favorite.
Yeah, we would do dun dun dun.
Yes. No, I want you to say the force of gravity dominates.
The force of gravity dominates.
You sound like Kylo Ren.
I know.
Because he has kind of a feminine voice.
He does, but it's deep, but it's still a little bit feminine. Feminine?
Yes.
I know.
Love it.
I know.
I want that to be my co-host for the puppets.
That would be how your puppet would talk?
No, I just want that voice to talk to the puppet.
Oh, you want to talk
off screen.
I was about to say, because the puppet should definitely, you could ask the puppet.
Can you tell us about magnetars? And then you would just keep talking.
Scared.
And then the puppet would be like, oh god, magnetars.
I think we could do this.
Let's make it happen.
I think this would work.
I've got $50. I'll fly out to Colorado. We'll do it. We'll shoot a pilot.
Absolutely.
We're gonna make it happen.
Yeah, and I think. Do you think this would have to be mature content, or do you think kids would be just fine with it?
I try to make everything I do universally applicable.
Okay, because I wonder. I know. I know. I definitely.
There's an additional layer of humor.
There is.
By making it vulgar.
Right, and that's what I do here.
Yeah.
But there is something to be said for something that's that can easily blend with both.
We can make it like right on the line where we tell jokes that only adults would get, and they go right over kids' heads,
like SpongeBob.
Yeah,
that's what they did. I would pay to watch that show. I'm sure a lot of people would. Why exactly?
We gotta get that quote. I want to put that in our pitch.
Yeah. So this is an unrelated question, and we'll make this the last one because this is getting into the slippery slope of time. So, ready? Why exactly is time?
I don't have to be the dense one.
Okay,
you can give me easy questions.
No, I know, but I sit here and I do this like for hours a day. Forever. So why exactly is time for someone? Oh God, I know it's going to happen, and I'll let you choose who's who. Okay, so why exactly is time for someone close to a massive object slower than time for someone far away? And what if?
Yes, because sky is going to be close to a black hole facing our imminent doom.
Wonderful, thank you.
Yes, and all is right in the universe.
Okay.
And the lesson from relativity is that moving clocks run slow. If you are going fast in space, you are going slow in time. So moving clocks run slow. Acceleration causes movement. Yes? So accelerating clocks move slow. Now here's the big jump.
Do it.
Acceleration is gravity. Gravity is acceleration. These two things are identical. So moving clocks run slow. Accelerating clocks run slow. Gravitating clocks run slow.
There we go.
There it is.
That was a nice summary. So, guys, I want you, Dr. Paul, to tell everybody where they can find you. Do the pitch, please.
Here's the wind up, and you can find me. I think the best website is my website, pmsutter.com. That has links to my podcast and YouTube show, Ask a Spaceman, to my radio show that is on YouTube and Twitch and radio, spaceradioshow.com. Links to social media, buy my book, buy a few copies of my book because it's worth it. And next week, are you ready for what's happening next week?
What's happening next week?
I am doing an AMA.
On Reddit?
On Reddit. I am entering the Lion's Den.
Yeah, you are.
Yes.
Good luck.
And I'm going
Godspeed.
to sing lullabies to them.
What subreddit, someone says, or asks?
On Ask Science.
Ask Science.
Yes.
Subreddit.
So this was actually arranged by Sony to promo the UFO movie that's coming out in September that I'm the science consultant on. So I'm doing an Ask Science about the science of the movie and then just whatever.
Awesome. And that's when? Tomorrow?
It's next week. It's a week from today.
Okay.
We don't have a time confirmed yet. It might be during this time.
Great.
During sky time.
How considerate. How wonderful.
So
it's okay.
There's two ways we can play. Either I'm willing to be totally insane and do an AMA while doing a Twitch stream with you. I don't know. I've never done an AMA before. Or how late do you stream on Tuesdays?
Unfortunately, not that late because the kiddos started school.
Right. Okay, we'll figure out some time next week to stream.
Well, no, that might be actually really cool though. But people would have to be
like
okay.
A behind the scenes AMA.
Yeah, because people would have to be okay with you not talking as much, and we just watch your face as you're typing. But then we can judge your responses. We can grade you.
Yes, grade me. And actually, I probably need help because I'm afraid of Reddit.
Oh God. Like, well, yeah, no, I'm not. I've had
I fear Redditors.
why do you fear them?
So
they're not nice. People on the internet are
because
not.
they're not nice.
Right,
Because
yeah.
they're not nice. They're not like chat here.
Right.
You know, exemplars of the human species.
A few.
Yeah. Reddit, I mean, it's just dangerous and I'm just scared.
Yeah.
And I've never done an AMA. I could use some emotional support.
Yeah. No, I think we should do that. I think that'd be good. And Reddit's, I don't know. It's weird. I take Reddit with kind of a grain of salt. Like I never really believe anything I read on Reddit. Ever. Like ever.
Especially an AMA by me.
Right. No, even going into the science section. No, I was talking more about the Twitch section. It's just like people, it's like a beautiful mind, right? People are like, I've got an idea and I think that this relates to this and this relates. And it's like, wow, you genius. But so
There's
like
a
it's,
conspiracy.
yeah. So, yeah, but that will be good. I think we could do that. I think we should do that.
I think that'd be fun. If you in chat think it'll be fun, I think it'd be fun too.
I think chat thinks that'd be fun. Don't you, chat? Everybody in chat? Every person in chat?
All the peoples.
All of you guys, yay or nay? Yes. Okay, so we're going to go with the first response.
We can brigade and upvote all of my responses. We shouldn't do that.
No.
Don't do that.
Don't
That was a bad idea. That was a bad idea, folks.
Bad idea. Toss that one out.
That was not broadcast live. That was just a private conversation.
Can we clip it?
I was just tossing out random bad ideas. I was given a list of bad ideas, and I was starting with that one. And then that's as far as I got.
Yeah, everybody said it. Well, no. Dodgy said it can't be worse than Sky's dun dun dun. True. Okay, well, thank you so much for your time, and we'll see you next week then.
Thank you. It is so humid. The rain is over, but now it is insanely humid. I'm sweating.
Yeah, well, we can't tell, but
I can.
Yeah. All right. Well, go.
Give me a squeegee.
Yeah. Go and sweat.
I'll go and sweat.
Okay. We'll talk to you later.
Thanks a lot. See ya.